So there are different type of classifications of machine learning models, and we can classify them broadly into unsupervised techniques in which we don't have any expert knowledge necessarily doing an interpretation of a prediction. Let's say in this case, we want to predict bottom hole pressure, but we have already a measurement of bottom hole pressure on the well. Let's say you want to make a classification, but you don't have an expert making a classification at an input decision of how that classification should be performed. So that's one of the applications of unsupervised techniques. The other application is dimension reduction or dimensionality reduction, which is when we have many variables that could be or features or predictors that could affect the model that we're building, so that are influencing the model that we're building. And in that case, we perform techniques such as principal component analysis, in which we reduce a number of features. In this case, we don't have many features. And in this particular example, we have only 1, 2, 3, 4, 5, 6, 7 features. But you may find yourself in a problem where you may have let's say the problem that I have faced in the past, where I have a geological model and I wanted to do an uncertainty analysis based on all the input variables of the geostatistics and structural framework. And I found myself playing with over 50 variables, but the number of models were limited. So principal component analysis is an ideal tool to reduce the number of variables that that we could use in those scenarios. And clustering is another unsupervised technique to split the data in a way that where you can put, if you plot, like the plot that I produce in the hyperspace, you can identify potential groups of data that are similar, but there is not necessarily an expertise of put into the interpretation from a domain expert into why the data these 2 points could be correlated. Now, on the other hand, we're going to use some supervised techniques. So we're going to use a decision tree, regressor. We can use also linear regression and also neural network models to do a couple of things. The one thing is a regression, which is this problem is a regression because we're predicting a bottom hole pressure, and the bottom hole pressure could have a value of 257.3 or could have a value of 122 bars in this case. So you can see that we are actually predicting a real number, while a classification is a case where we are predicting a category. A simple category could be a yes or no. Let's say we're going to find oil or no. Will we find oil or no? Yes or no? Or more complicated categories could be, let's say you have a well and you train to identify what was the most successful artificial lift technique in a particular well, and you train up a bunch of wells, and you have artificial lift technique 1, artificial lift techniques 2, and so on, and then ultimately you want to predict in the next well what is the best artificial lift technique that you may apply based on the knowledge from the other wells. And as Franklin also is mentioning here in the messages, is a phases classification. It's another topic where you have different shale is sand, or carbonates and limestone and so on, where you may have a particular interpretation of a petrophysicist, and from that interpretation of a petrophysicist, and that's why it's supervised, because you have someone with a domain expertise, you will do a prediction based on that interpretation. Okay, so it's a bit of also more or less what we have done so far, it's this period here where we have exploratory data analysis. We did a histogram, cross plots. We have done, we didn't do correlations, but we could have done box plots, which is very important before you do the machine learning. Then we have the linear regressions, decision trees, and neural networks. Okay, so let's go to some of those as time permits, because we have probably 45 more minutes before we hit into a machine learning, or before we finish. And yes, Hashim.
A very quick question. In your expert opinion, for the feature importance versus dimensionality reduction, which do you think it should be given more weight at the beginning of the project in terms of dropping some features based on the importance, and in terms of the dimensionality reduction, should I run first the principal component analysis and see the variances and biases and kind of come up with some trade-off? Which do you think I should put more weight on it, feature importance or dimensionality reduction?
I think at the beginning, so let's say the feature importance by itself could be a dimensionality reduction, because by doing a feature importance, you can take the most influential variables and then create a subsequent model based on those initial features. When you do dimensionality reduction, I think you will do it based on two conditions, or two things are driving you. The first thing is that you have many more features than actual observations. So in this case, we have 6-7 features, but we have thousands of observations. So this is not the case for dimensionality reduction. The opposite would be, let's say you have 50 features and you have only 50 or less observations. So that immediately would lead you into executing a dimensionality reduction technique. Okay, PCA is one of those, but another thing that you could do is do a best subset forward regression, which is you start to add, you do a regression with all the variables at a time, and then you see what is the most important. Then you do it again with that one plus the second one, and then you see what is the second most important, and so on, up to the point that you start to add your model by adding features. Another technique is removing features, but that is quite useful when you have a lot of features. Best subset forward regression. I've never done it in Python. I know in R R was very good for that. The other thing that Franklin is mentioning here is performance. So if you have many features and your model is it's taking time to be trained and so on, you may want to consider reducing dimensionalities. So lasso and rich linear models will help you to reduce. I think it's rich that will help you to reduce the dimensions as well before you actually execute another more complex machine learning model.